Yes, sir. 1 second. I'm searching for the question.
Order for food. Happy.
So, how do I answer the first question?
Which is what, dear? Read once.
A toy car is moving on a closed track whose curved positions are semicircles of radius 1 meter.
Hmm.
The adjacent graph describes the variation of speed of car with distance
So
moved by
how
it.
do you mark means I think questions should be taken when I'm there physically present. Why? Because it'll take much of your time narrating the questions to me, and I'll have to go through the PDF. Wait a minute, I open my PDF in that case. Wait. That'll be a better way of executing it. I open it. So this is, where is it? Yeah.
So you're not sharing your screen.
No, I'm not sharing the screen. I'm reading the. I have the paper with me. Are you on which one? First one.
Yes, sir, the first one.
Two small rings. That one.
First one. No, sir, it's the toy car one.
You're referring to advance or means?
Advanced.
Toy car. Yeah. What is there in this? A toy car is moving on a close. What happened? This one?
Yes, sir.
What happened in this one?
So I couldn't figure out the approach on how to start.
That is something that we'll be discussing, dear, when we meet. Tell me some doubt if you do have.
Uh,
If you
no,
read
sir.
the question,
Then,
you have any doubt the question is wrong or something is not mentioned in it, you can feel free discuss.
oh, like that, sir. Then I have
Yeah,
no doubts like that.
yeah, because this is individual doubt. Don't take time of class for individual doubt, right?
Okay, sir.
Yeah. If this is a collective doubt, then it's fine.
Okay,
Okay.
sir.
We need to have come over here with some ambition of completion today, and accordingly, we'll take the question if you do want, but better when we are around, right?
Yes, sir.
Yeah. Okay. Tell me, dear. So how was it? How was the experience? Share the experience with me. Is all good? How are the questions? How do you like the question? Yes, dear. Tell me something about how did you like the question? Did it go good? Who all didn't take it the way that it was expected them to take, which was completely new experience to them? Was it something seen earlier? Was there any question which has been through earlier?
No, sir, not really.
Okay. Anyone? Aditi?
No, sir.
Kenneth? Arnav? Avik? All good?
Yes, sir.
Yes, sir.
How was the experience? Didn't share with me? Yes, dear. Tell me, collective. Share with
So it was hard, sir, like very hard.
questions were tough. Okay, maybe. Okay, that's the drill, better. You'll have to get done with the preparation that you want to be at. You are well aware of. So you'll have to get done with the preparation which that place calls for. Okay,
Okay, sir.
and you should know the drill. It's not that easy because we are aiming for ranks. We are not aiming just to cling to IIT. Getting it?
Yes, sir.
Okay, so let's move forward, class, with the portion. And the portion that we are to get done with, we were already in. We introduced friction. We got to know what friction is, and I left you with a question, correct? And the question
Yes,
was, let me know, the question was about there being an inclined plane on which there's a block placed, and over the block is another block. They are of different
Yes.
masses. We mark it as M1, M2. Correct me if I'm going wrong on markation. Angle being theta, right? And what we given to you, this is smooth, mu is equal to 0. And this was given with some value of mu, correct?
Sir, we cannot
Sir,
see the
you're
screen.
sharing. We
We
can't see
can't see
this.
your screen.
Come again? Oh,
So we cannot see the screen.
Oh, got it, got it. I'll just share with you. Okay, I'll share the screen with you. Visible now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So this question was given to you in the class and you were asked what will be the direction of friction on one block due to the other. I think I asked for what will be on M1 due to M2, correct?
Yes, sir.
Yes, sir.
Okay, so what is your answer? You have copy. You have copy. I may have. What will be the answer for friction? Anyone? Anyone who came up with the answer, please? Nobody? Did you give a shot to it, class? Plus, again, going mom over here when I'm not around is not good. You need to respond, right? I'm not able to see you. Do you want me to clip and ask you show your videos so that I am in a position to get know on your reaction to the question? I don't think you wish. So please let me know. What have you done? Did you get anything from here? Is there any takeaway? Every question will have some takeaway or the other. This has been taken with a point of view. You do understand what is relative acceleration and in accordance direction of friction, correct? Am I audible?
Yes, sir.
Yes, sir.
So please tell me. If that
Sir,
is not
is
the
it
takeaway, if that is not the takeaway, there's no point taking this question. So please answer to what I'm asking. M1, M2 given to you, it's placed on a smooth surface. There is no friction between M1 and the inclination, but there is friction between M1 and M2. You have been asked when the system is led to itself, then what will be the direction of friction on M2 due to M1? And we are coming from an understanding that friction is to act in direction.
So I might be wrong, but is it 0?
Opposite to relative acceleration. Okay, dear? Who was
Yes,
it?
sir.
Who did submit the answer? Was it?
Sir, Ahan, I said I thought it was 0.
And 0 is what you are vouching for, right? You have placed your option as 0. Correct me if I'm wrong.
Yes.
Okay, may I ask you, Han, where from you're coming?
So it felt like both of them would have an acceleration of g sine theta along the inclination, and so relative acceleration would be 0.
Very good, dear. Very good. Absolutely correct. Absolutely correct. Okay, you're right. You're right. And you came to me as a surprise. Not very many are able to look it from the perspective that you did there. Good. What he has said is absolutely the case, class. I told you in the class that when we are to decide on friction, then what we are to do, we are to neglect friction, we are to discount on it. And then look for what is the acceleration and in which direction it being. Here, if I go for M1 in solo, I get to see that an M1 forces which are acting, one is normal in this direction, and the other is mg in this direction, isn't it? We break the component of mg cos theta, this being theta, mg cos theta, the other being mg sine theta. Okay. This is, what do we have? Just a moment. Okay. Okay. Okay, this is join. So who wants to join? I'm letting it join. It's open for join, right? I don't have to give them permission to join. Where is us? It's okay, they may join. Yeah. Yeah. So mg sine theta, this was about m1. There's no force of friction on m1, and I'm not to show direction of friction. As you know, we are trying to guesstimate in which direction friction will apply. So we are discounting on it for now. The only unbalanced component, mg sine theta, is to get me what acceleration known to all of you. Normal and mg cos theta, they will be balanced. There is no motion in that direction. So mg sine theta is the only component of mg which is to garner acceleration to this body. Accordingly, acceleration which this body will get down the inclination is to be marked as m1g sine theta divided by m1, which is to get me g sine theta, right class?
Yes, sir.
Yes,
So
sir.
this is for m1, and it is no exception to m2. This is no exception to M2. Why say so? M2, how many forces are acting? One will be normal, as I can show. This is the direction of normal, which is applied by M1 on M2. This is the direction of M2G sine theta, M2G, and this is M2G sine theta. M2G cos theta accordingly will be in which direction known to all. This is the direction of M2G cos theta. What do we get to see then? This has also got only one component unbalanced, and that being m2g sine theta of mg, which is to garner it what acceleration? The same g sine theta.
So the same that M1 is going at.
Yes, m2g sine theta divided by m2, it is the same. It is the same is indicative of relative acceleration between them being zero. Agreed? There's
Yes, sir.
no relative acceleration. Relative acceleration is acceleration of first minus acceleration of second. They are in same direction. You add them vectorially, you get a null vector, right class?
Yes, sir.
Which is what to say, there'll be no friction acting at the surface of contact. Which is the surface of contact? I highlight it. This is the surface of contact. No force of friction will act at surface of contact. Right, class? Got it?
Yes, sir.
Yes, sir.
Okay. This is how we decide on direction of friction, class. This is how we decide on direction of friction. Be they be in motion or not. We always are to be careful of the force which is unbalanced, which is what can tantamount to acceleration. I told you in class, it is just possible that there is no motion. There is motion, it's easy for us to speculate in which direction friction will act. If there isn't, it's difficult, a tad bit difficult, and then we repose faith on acceleration being the immediate effect of force. In accordance, try to find relative acceleration. Got it, class?
Yes, sir.
Okay. Now, I wish to get few questions, at least from the tests you wrote. And they were ones which the class in general have a confusion is what I can gauge. Correct me if I'm wrong. If you want a discussion for class per se, I can go ahead with it. You have not been into hurdle as yet. If you have discussed question among yourself, and if there's a common question for class, according to my speculation, supposition, there can be few common, and those common can be taken in the class hours. So that's up to you to decide. What comes to me is there was one which was having relation V1, V2 depicted. Then there was one with a circle and parabola. So those can come as few surprises. If they were not, I will be very happy in my skin. Nonetheless, if they are, and they are unilaterally to be discussed by class. Get to me in unison. If you are all on same page, can go for discussion of a few.
Sir,
Yeah.
I have a doubt in this question only.
Okay, in this one, yeah, tell me.
Yeah, I understood why relative acceleration could be zero,
Correct.
but I don't understand why friction between the two bodies would be zero.
If relative acceleration is zero, in what direction will you apply friction, dear? Friction is always applied in the direction opposite to
Opposite.
relative acceleration, correct?
Oh, okay, yeah,
So if there isn't any relative acceleration, there's no tendency to move, correct?
yeah. But if both M1 and M2 start slipping,
Yeah.
then M2 would fall from M1, right?
No, it won't. They will move together.
But inertia.
There is no relative motion, dear.
Okay, yeah, I got it.
As there is no relative motion, you can assume them to be operated with the only force which provide them an acceleration. And if there is an acceleration which they are both moving with, then there is no need for friction to show.
Okay, yeah, I got it.
Getting it? Okay, fine. So I move on to the other one. If at any point in time you feel that, yeah, there is some common doubt which you want to discuss from the advanced paper, you may ping me on it. This is another case which I am bringing with you. And in this case, what being given to all of you is, there is a cart which is moving with an acceleration A, or it started moving with an acceleration A. This block is at rest. With respect to cart, it is at rest. Is it okay?
Yes, sir.
Show the direction of friction acting on the block. What is the direction of friction which will act on the block? Cart is moving with an acceleration A, and on cart is placed a mass. So what will be acceleration of cart same as that of block, or vice versa, right?
Yes, sir.
So in which direction friction should act on mass, on block? What should the direction?
Same direction as A.
Same direction as A. Where from you're coming, dear? Can you share your opine?
Sir, if we take the perspective of the cart and we assume that friction is not there, then the mass would appear to be accelerating with A in the opposite direction as the motion of the cart, and so the friction must be opposite to that, which will be in the.
Very good. Absolutely correct. Absolutely correct. If I am on the cart and I am not to apply force of friction as we are to decide on it, then I'll find cart to be moving backward, right, class? Block to be moving backward, correct?
Yes, sir.
And as I'll find block to be moving backwards, I'll apply a force of friction on the block in which direction? Forward direction, right?
Yes, sir.
We can change position. I can wish to be on block, no issues. Then I'll find what to be moving forward, cart to be moving forward with respect to me, correct?
Yes, sir.
In that case, I'll apply force of friction on cart in the backward direction, correct?
Yes, sir.
And for that, there'll be a reaction on block, which certainly will be forward, isn't it? Will it be? Isn't it, class?
Yes, sir.
Yes, sir.
Yes, yes, sir.
So whichever way you look, you get direction of friction on block in the forward direction. Let me ask you, how can you justify it from an inertial frame? If I'm not reading relative, if I'm over here and want to justify motion of block as viewed from inertial frame, I'm on Earth. I don't want to pitch in relative concept. Can I go unilateral on a concept which is based on Newton's first law of motion? Unilaterally. Only
Yes,
that.
sir.
Yeah. How can you justify in that case?
So we can say that to us the block is moving in an inertial frame. The block will be moving forwards
Correct.
with an acceleration of a, and
Yeah.
so it might be feeling a force in the same direction moving forward.
Exactly. Good. There is no force to come to our rescue. There's normal which is acting in the forward direction. Mg will act in the vertically downward direction. The only force that we can then find refuge in will be force of friction. And force of friction will act in which direction? Will act so as to provide acceleration as read from inertial frame, right dear?
Yes, sir.
Yeah, sir.
Okay, so force of friction on block will be in forward direction. As there is no slipping, which force of friction shall I mark, Fs or Fk?
FS.
FS.
So Fs is what I'm marking. Going by Newton's first law of motion, second law of motion, we mark it as m into a. Newton's second law of motion, Fs is equal to m into a, correct?
Yes, sir.
Okay.
Yes.
You feel that there'll be a time, if I keep on increasing acceleration, there'll be a time when will I observe some motion, and that will be departure from what I'm into observation now. Do you feel so?
Yes, sir.
What happened? What comes to you?
So after some time, the block will slip backwards off the car.
The
So
block will
when
slip backward. Just a moment. I have something to ask on this. Block will slip backwards, is it?
yes, sir.
And can I ask you to
With
share
respect to the car.
your what you have contemplated? Can I ask you to share the genesis of it?
So currently the block is feeling a force Fs which is in the forward direction. But
Correct.
after some time that will reach Fs max, and so kinetic friction will act. And as that is always less than static friction, the force moving forward will lessen.
No,
So
but
to the
Fs max when will act, then static friction only is to take value of Fs max, right?
yes,
This
yes,
per se will change or appreciate to Fs max, right?
yes, sir.
Will the direction change?
No, sir, I meant like with respect to the cart, the block will appear to be moving slightly backwards.
With
As,
respect to the cart,
yes, sir. As
are you pitching in cart now? Earlier you didn't say with respect to cart.
yes, sir, I think I forgot to mention it earlier.
Okay,
Yeah.
and what about from the frame where we were observing it?
So it will appear to be accelerating less in that direction.
Okay, so direction remains, right? Please do remember, class,
Yes,
when
sir.
we say it'll start moving backwards, it certainly is not from S frame, which is fixed to Earth.
Yeah. Yes, sir.
It
I
will
totally
start
agree.
moving backward without doubt, subject to your observation being positioned on which frame? On the cart, on this non-inertial frame, right?
Yes, sir. I spoke.
From
Yeah.
non-inertial frame, it will appear to be moving backwards, and it does move backwards. You can very well justify why will it move backwards as viewed from non-inertial frame. So far as inertial frame is concerned, Fs is equal to ma will hold, and then we say that Fs maximum is always less than or at most can be equal to Fs, correct?
Yes, sir.
What is Fs maximum? Known to us mu into mg, right class?
Yes, sir.
Yes, sir.
And mu into mg should be should be, did I write the opposite? Yes, I wrote the opposite. Someone said yes as well. How dear, yes? I wrote the opposite, correct?
Sir, I was listening to what you were saying.
Right. I wrote it is.
Less than equal to. Sir, I was
I wrote
looking at
the opposite over there. Where's the eraser? Okay. Yeah. I wrote this as opposite, correct?
Yes, I was listening to what.
Greater than or equal to Fs, right? So mu into mg will be greater than or equal to Fs, which is from equation 1, mass into acceleration. Agreed, dear? Agreed? Please be careful when you say yes.
Yes.
Take my statement with pinch of salt, please. So what do we get from here? M gone. We get A as something which is less than or equal to mu g. And to be specific, mu sg, right?
Yes, sir.
So till what time they are to move together, you get from here. Till what time there will be no relative motion between cart and block, you get to see from here, right, class?
Yes, sir.
Till what time there will be no relative motion, can I get from all of you as an equivocal voice so that I register it being well received? Tell me, class.
So till the time A exceeds G.
G, is there only G here?
Yes.
Sir.
Is
Mu
there
is
only
G.
G
Till the
here?
time A exceeds mu is G.
Yeah, till the time A exceeds mu s G, they are to move together, correct?
Yes, sir.
Yes, sir.
Okay. Fs will continue to remain in that direction. Fs max will also share direction with Fs. Fs keeps on increasing with acceleration till the time it is able to support motion of block. Thereafter, block will not move with same but an acceleration lesser than what Fs max can provide. Correct? Direction will remain the same, class. If you say direction changes, then I'll ask you which force can change direction. It is not possible for it to start moving backwards, correct?
Yes, sir.
Yes, backward motion you can justify from where you are observing it. And backward motion you will observe if and only if you are in a frame which is non-inertial, right, class?
Yes, sir.
Now here you can say I'm in a frame non-inertial, so I'll apply pseudo force in the backward direction. That being MA, force of friction in the forward direction is Fs. And then what we are to get from here, what can Fs increase itself to so as to annul the effect of MA, correct? If I'm
Yes,
in
yes.
non-inertial frame, what do I see? I see this block to be at rest, no acceleration. Correct, class?
Yes, sir.
Yes,
Yes.
sir.
And then what I write is MA is equal to Fs as the block is in moving with respect to me. Right, class?
Yes, sir.
Okay. Or I should write an equation before of it, which reads Fs vector plus F pseudo is equal to 0, right, class? Right?
Yes.
Which will get me, as you all know,
This
MA
is
is equal to Fs. Yes, please.
this is initially right
This
when
is
force is
equation
MA.
of equation of motion. Then I place the values. We know MA is backward and Fs forward, right? So what do we get from here? Fs minus MA is equal to 0, correct? Is it okay, class?
Yes, sir.
Yes, sir.
And from there, we get to see what can Fs be. We write the same equation as Fs equates to MA. Fs we know will be less than or equal to Fs maximum. Correct, class?
Yes, sir.
Yes, sir.
Go by same narration, MA should be less than or equal to mu mg. We get again A should be less than or equal to mu sg for there to be no relative motion. Getting it, class?
Yes, sir.
But here we can
Yes.
justify if MA goes beyond Fs maximum, right, class? If MA goes beyond Fs maximum, getting class? If MA is greater than Fs maximum, then what you'll be observing is it starts moving backwards. Agreed?
Yes, sir.
But that you ought to observe with respect to which frame?
Non-inertial.
Non-inertial frame.
Getting it? That we will observe with respect to which frame? Non-inertial frame. So far as inertial is concerned, it continues to move forward. Getting it, class?
Yes, sir.
Yes, sir.
Okay, good enough. Shall I flip now?
Yes,
So,
sir.
Yes,
one
sir.
second. So I don't understand
Which part, dear? Which part?
how we can justify the block moving backward
Okay.
from an
Why
inertial
is the block at rest initially? When I'm on this frame, why is the block at rest? Can you justify my observation? I found it to be at rest. Why so?
So because Fs is equal to Ma.
Correct. Now what you are trying to do is you are trying to appreciate A. You are increasing A. 1, 2, 3. You are
Yeah.
increasing it. Getting it?
Yeah, so from non-inertial, I understood that because of pseudo force, we can say that it will move back. From inertial, I didn't understand.
Inertial, I never did admit that from inertial frame you can see it moving backward. Did we negate that? You will never see it moving backward from inertial frame.
Oh, okay.
From inertial frame, what you can see is it continues to move forward. When Fs was operational, then it was moving with higher acceleration. Then when we went beyond that acceleration, got it?
Yeah.
When Fs was operational, then it was susceptible to move, correct?
Yeah.
So at that time, you will observe it to be moving with maximum acceleration. Got it?
Yes.
If you increase acceleration further, then it will move with an acceleration which is in the same direction but lesser than what Fs maximum provided. Got it?
Okay. Yes, sir.
Because then what will act here is Fk.
Yeah.
And Fk, as we are coming from last class, will be less than
Lesser
or
than Fs
actual
max.
is saying to be lesser than Fs maximum. Getting it?
Yes. Sir.
So slipping will start, though the direction as observed from S frame, which is inertial, remains.
Yes, sir.
Okay, good enough. Shall we flip now? Any doubt in this one?
You can flip, sir.
Check, dear, check. If you do have any, feel free ask. All done?
Yes, sir.
Okay, good enough. I flip it then. We have the same concept when you take it on a disk and the disk is made to rotate about vertical axis, let's say. There's a block which is kept over here. Here they ask that what should be the value of omega for this not to slip. What should be the maximum value of omega for this not to slip? Mind you, over here, what we are doing is, we are not gradually increasing omega. We are increasing omega in piecemeal. First, I take omega 1, read. Then I take omega 2 and then get the reading. Taking omega 3, getting reading. So I am taking them in isolation. It's not that I'm perpetually increasing omega. Got it?
So what's omega?
Omega is omega 1 to begin with.
No, but what does it mean? Like
Angular velocity, right?
Constant. That is not changing. What I mean by this is I'm not changing speed of rotation. I am not to allocate tangential acceleration to this mass. Got it?
yes, sir.
To increase speed gradually, then you will have to acceleration, which is in accordance with increment of speed, and that being tangential, right, dear? Right, Vishwa?
Yes, sir.
I wish there be no tangential acceleration accorded to this block. I read the direction of acceleration first with omega 1. What direction of acceleration you have to assign to it with omega 1 constant? Tell me. What will be the direction of acceleration? Will there be any tangential acceleration associated with my block?
Sir, could you tell the question again?
What will be the direction of acceleration which you will assign to this block with omega 1 angular speed if the radius is or the disk is moving with omega 1 angular speed? Then what will be the acceleration accorded to block? In which direction? Will it be both tangential and radial or only radial? Will you be able to circle on rotation? We have taken rotation, we have taken circular motion, correct?
Yes, sir.
Yes, yes, sir.
And in circular motion, I told you that there can be two acceleration associated with a body which is negotiating circle, right?
Yes, sir.
One tangential and the other radial, correct?
Yes, sir.
When is tangential 0?
When the speed is the same always.
Okay. So I'm asking you to take same speed. Okay, this is moving on a circle. Agreed or not? Agreed? It is kept. Let me tell you what the situation is because I don't think you are able to receive it. There is a disk, okay? Getting it? Getting class?
Yes.
Yes, sir.
There is a disk. On this disk is placed this mass. Mass is not moving relative to disk. Got it? Disk is rotating with an angular speed omega about this axis. Am I clear now?
Yes, sir.
Yes, yes, sir.
Okay. So this is the situation. There is no relative motion between mass or block and disk. Can you draw a free body diagram for mass m class? Free body diagram for mass m. What
So
are the
as seen
forces?
from, so forces with, as in when we're viewing from the disk?
Yeah, when we are viewing from Earth, let us say, because I wish get acceleration to it. Normal, mg. Okay. First from inertial, so from Earth.
Fs is acting in the direction of W, omega.
Fs will act in which direction? The direction of
Like-
omega. Omega is the direction of curling
Like-
of finger. So
Yeah,
you
no,
should
like
say omega
forward.
Yeah.
Forward, yeah.
forward.
Yeah.
Radially inwards, outwards.
Inwards.
Radially inwards. Why say so?
Yeah. Because it's not slipping back.
It's not slipping.
Yeah, if we sit on the disk,
I don't think you should position on slipping. You should position of acceleration viewed by you, correct?
yeah.
So acceleration which we will associate with this mass will only be radial, right class?
Yes.
And if that is the direction of acceleration, it should come from some force. As it is the effect, it should come from some force. It should have some cause, correct?
Yes, sir.
And the cause being Fs.
Physics.
What we then write? Fs is equal to what shall we write, class? M omega square r, right?
Yes, sir.
Yes, sir.
Yes.
Okay, we are aware of Fs being less than or equal to Fs maximum. It's a very important inequality, as I was marking the other day with you. M omega square r is less than or equal to mu normal. Normal is m into g here. M gone. We get from here that omega should be equal to mu sg by r under the root. If you go beyond this value of omega, then it will start slipping. And slipping in which direction, class? Inwards or outwards?
Outwards.
Slipping in which direction, class? Tell me, all of you. I want an equivocal answer, please. Slipping in which direction? How will it start slipping? How will it start moving?
Outwards.
You're viewing from which frame? You're viewing from inertial frame. As you keep on increasing omega, Fs will keep on increasing, correct?
Yes, sir.
So there'll be a time when Fs is equal to how much? Fs is equal to Fs maximum, right, class?
Yes, sir.
You will not be able to support motion any further. Why? Because you're increasing omega, but Fs has got a cap, which is of Fs maximum, right, class?
Yes, sir.
Now, it is not that easy here to see from where you are trying to. You're ordained as you're hell bent on viewing it from S. And you told me that you'll be able to see it moving outwards. How will you justify outward motion from inertial frame? May I please get to know? If at all it is to move outward,
Centrifugal
the
force.
direction of friction should change. Are you of the opinion that direction of friction will change if I am viewing from inertial frame? Yes, dear. This time it's not that simple. What will you say? How will you justify? Fs maximum. What will it change direction? And then will we justify block moving or spiraling out? You say, if you don't want to say moving outward, say it will spiral out. How will you justify? That is what the question. From inertial frame. Fs maximum continues to act backwards, correct? Getting it or not? Or are
Yes,
you
sir.
of the opinion Fs maximum will change its direction? Please say so if you do feel. If Fs max is not to change its direction, then how on earth we'll be in a position to justify block spiraling out? Think about it, class. It's very important question. It's very important question. Easier. There are cases when it is easier for us to justify motion if viewed from non-inertial frame. And that's the reason we do take into account non-inertial frame. Doesn't take away from fact that the same can very well be justified when we are dealing with inertial frame. Maybe we'll have to coin something which is difficult to understand otherwise.
So
We'll have
is
to
that
coin
a
something which is difficult to understand otherwise. I give in there. You'll have to coin something, else you will not be able to, and that what is ever it be. whatever it be, what you're coining is based on experimentation, mind you. You will not be able to justify it theoretically. If you want this observation to be viewed from inertial frame, then you will have to take help of experimentation class. And experimentation will tell you what in exact is happening. It's very important statement that I'm making now, which you will check for veracity. And that statement is, it is not possible for block to remain in touch. There will be a contact and there will be a miss of contact. Contact and then lose of contact. There will be a loss of contact. Contact will get lost for a fraction of a second. And this will be something which is perpetual, which is punctuated. It will keep on happening. There'll be a punctuated miss. There'll be a punctuated left off block from the point where it is positioned. It will keep on leaving, and this punctuated will let it move or will have it a motion which we will then justify. That is what is given the epithet of spiraling out. It will spiral out. There is no two way about it. If we are not able to justify spiraling out, you will never be able to justify motion of a person who is in death trap, death wheel, right? What happens to the person? The person moves out. Yes or no?
Yes, sir.
Person moves out, the death trap. Have you heard of it? In the circus, we do have, right?
Yes, sir.
So if
Yeah,
you keep
yeah.
on increasing his speed, then you will move out. You will spiral out. Agreed? Yes or no?
Yes, sir.
Can you justify spiraling out motion? And mind you, on Earth, you are on Earth, correct? So you are viewing the person coming out from Earth. Agreed or not?
Yes, yes.
Yes, sir.
Now from Earth, if you see how many forces are acting on man, one is normal and the other mg. Third force which can act on man will be in which direction? Force of friction, correct?
Yes,
And
sir.
force of friction will act on him on which direction? On the person in which direction? In this direction, correct? Will it act in this direction? If it acts in this direction, then you will justify, okay, the person can move up. But let me ask you that this person, if the person is moving up, then that is position to Fs is what you are saying. Are you saying so that Fs will make the person move up? When will Fs act? Fs will act when the person is having tendency, correct? The person, if the block is at rest and the person is at rest, then the person will have a tendency to slip down, correct? If it is at rest, if you leave the person over here, if you leave the person over here, if you leave the block over here, then this block will have tendency to slip down, and in that case, Fs will act upwards. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
And this Fs,
Yeah.
what will happen with time? This Fs can provide an acceleration in which direction? Upward direction if you keep on increasing it, correct? If you keep on increasing it, correct? Yes or no?
Yes, yes, sir.
But tell me, why will Fs increase?
Because force in the downward direction is increasing.
Yeah, which is mg sine theta.
Yeah.
As viewed by you, it is constant. As viewed by you, it is constant, correct?
Yes.
Yes or no? Tell me yes or no, class. As viewed by us, it is constant, which is equal to mg sine theta. Normal cannot have any component. Agreed or not?
Yes.
Yes, sir.
So if it was having a inkling of slipping downward, that being arrested by Fs, and that is kept as it is. Now Fs is balancing mg sine theta. How on earth the person started moving upwards? What trucks the person has, what trucks Fs has with acceleration? Getting the predicament class over here or not? I'm able to bring it to you or not the way that I wanted to bring. That Fs is balancing mg sine theta, that's it. It is to be kept there.
Yes, sir.
If I increase acceleration, then what is to happen? Is to be read now.
Fs will
I'm
increase.
increasing acceleration. I'm increasing acceleration over here. This was the acceleration, and this acceleration is equal to how much? Omega square r, let us say. Correct?
Yes, sir.
Okay.
Yes.
Now you can justify why will happen. Certainly mg will not come to your rescue. What can come to your rescue is component of
Omega square R.
yes. Got it? Component of normal and component of Fs. Getting it, class?
Yes, sir.
Now we can write equation pertaining to normal and Fs, component of Fs, which can be equated to omega square r. The same is very simple if you place yourself on the moving disk or on the moving funnel. See how it becomes easier for us if I place myself on this disk now. How simple it reduces to, what simplicity it reduces to rather. What will I say now? I'll say we'll apply pseudo force. Agreed?
Yes, sir.
Yes.
Apply
Yes.
pseudo force or not? Yes, we will apply pseudo force. In which direction? Opposite to acceleration. What will that be? M omega square r. Agreed, class?
Yes.
Okay.
Yes.
And Fs continues to act in the direction shown. Agreed, class?
Yes.
What do we say now? Fs minus m omega square r. I'm going from non-inertial frame. The body is not moving, correct? No acceleration, correct?
Yes, sir.
So what do we get to see then? Fs is equal to what to us? M omega square r. Accordingly, Fs should be less than or equal to Fs maximum, which is what to get us? M omega square r is less than or equal to mu s into mg, right, class?
Yes, sir.
Yes, sir.
On, we get to see from here omega square r should be less than or equal to mu s g. Accordingly, omega should be less than or equal to mu s g by r whole under the root. Yes, here you can say with solidarity, if Fs max acts and that omega we exceed, omega square r we exceed, then what will be your observation is it will start moving radially inwards. Agreed, class? It will start moving radially inwards or outwards. What do we say? If you're increasing this, I said, which is beyond Fs maximum. Now, which has got a cap? This has got no cap. Agreed?
Yes, sir.
Yeah.
Increase. Whatever omega you want, you can appreciate it too. But this has got a cap. Agreed?
Yes, sir.
Kept on increasing omega, Fs kept on increasing. Now Fs goes to Fs max for that system. For that system. Of course, you can change Fs max if you are changing system. If you're sticking to system, we are to stick to system, we are not changing system, then it has got a cap. This value has got a cap and you cannot appreciate it. In that case, Fs maximum, the backward, which is to balance pseudo force, has a limitation, and that limitation, if pseudo force increases, you will find block to be moving in which direction? Radially inwards or outwards? Tell me, class. Radially inwards is fixed. and you have
Outwards.
transcended that
So
value.
Outward, radially
You have
outwards.
transcended that value, correct? So how will it move with respect to you, and where you are positioned? Let us not lose sight of. We are positioned on the disk, correct?
Yes, sir.
So how will find it to be moving? Yes, class.
Radially outward.
Radially outwards. We'll find it to be moving in which direction? Radially outward direction. Please mark the word over here. Operational is radially. We will not see the spiral. Am I clear, class?
Yes, sir.
We will not see it spiraling out. We will find it to be moving in which direction? Radially outward direction, period. Clear?
Yes. So this is why when acceleration mw
This is
square
when
r.
we are in non-inertial frame, when we are moving with the disk. When I'm rotating with the disk, is it okay?
Yes, sir.
And if I am viewing it from inertial frame, then we'll see it spiraling out. Then we will get to see it spiraling out. Okay, class? And that certainly is based on, as I have indicated, make and break. Without of that, it cannot be justified. I'll come into detailing on it later. Let us move in steps for now. Take it on face value. It'll be discussed in detail classes to come. Got it, class?
Yes, sir.
Okay, good enough. So this is about direction of friction, and in accordance why at times we are to lay more credence to frame which is non-inertial than inertial. It'll be easier for us to justify motion of block and to gauge, rather I would say, motion of block from non-inertial than from inertial. Okay, class?
Yes.
Okay.
Yes.
yes.
Okay. Now to something which is for you to decide first. If at all you do need help, we'll try help you with whatever I do have as my experience anecdotes. This is mu equal to 0 and this is mu equal to mu. I'll come to this question. For class first, there is a simple question to answer. Will not be helping you on this one. This is m. This is mu. Right, for this question, what should be the minimum value of force applied? What should be the minimum value of force applied on the block for it to start slipping? What should be the minimum force applied on the block for it to start slipping? Tell me, class.
Anything
Good.
greater than
You
mu
can
Greater
mg.
than mu mg.
Yes.
Come again?
Yeah.
Greater than
Greater
mu
than
mg.
mu mg.
Greater than mu mg.
Greater than mu mg. You should apply force greater than mu mg. Is it so? Am I getting this as the answer
Yes, sir.
from all of you?
Yes, sir.
Should be greater than mu mg.
Yes, sir.
Yes, sir.
That you say why? You know why all of you are in concurrence with it? because you have all presumed it to be in this direction, forced to be in this direction. Correct.
No, plus or minus mu mg. Plus or minus mu mg.
No, that's okay. Plus minus I do take. You assume that I have applied or I can apply force only in the direction parallel to horizontal. Did you
So if it's
assume it?
upward, then it will
No, so
instantly
you could apply it upward.
Yes, I can apply it in any direction, right? Yeah. I didn't restrict you on direction. You applied this way, this angle being theta, this is force to us. Now work it out, please. Can I get a value lesser than what you suggested? Now what you suggested being F should be equal to mu s mg, right?
So the
Right?
minimum is any value of force, I mean, greater than 0 in the upward direction.
Can we solve for what you have spoken about, dear Swara, which one? In this direction is F cos theta, right? And in this direction is F
Sine
sin
theta.
theta, right? You can apply the same with the change values. Now what you can say is F cos theta will be able to move it, and F cos theta should be equal to, if you want it just to move, mu into normal. We know what is mu into normal over here. See what I'm writing, I'll rewrite it. I'll rewrite it, which is what? F cos theta for it to move. F cos theta should be either greater going by you or at most equal, we assume it to be moving. Should be either greater or equal to how much? Mu into normal. Agreed?
So normal would be mg minus f sine
Yes.
theta.
Yes. So F cos theta should be greater than or equal to mu s. And normal now, as you did rightly gauge, how much is normal equal to? Mg minus
F
F
sine theta.
sine theta. Will it not change the value of F? Do check. I take F mu s F sine theta to the left, correct? And to the right is what to me then? Mu s mg. Agreed, class?
Yes, sir.
So what to see from here? F mu s sine theta plus cos theta is equal to mu s mg, right?
Yes, sir.
And then we know F is equal to how much? Mu s mg divided by mu s sine theta plus cos theta, correct? We have worked on this, if you can recollect, when we were dealing with drift. Have we worked on this? For F to be minimum, how to change it? I have worked on this so far as I can recollect. Have I not? If I have not, then mu s mg you can write. And then we have a better way to comprehend this equation, which is what? Mu s square plus 1 square under root, bracket open, mu s divided by mu s square plus 1 square under root into sine theta plus 1 divided by mu s square plus 1 square under root into cos theta. Did I take this with you, class?
Oh yes, so we're done it for one question.
Yes,
Express
exactly.
it this way and solve it.
So Fs minimum will be how much? It will relate to this is Fs. Fs minimum will be how much to us? Fs minimum will be maximum value of denominator, correct? Correct.
Yes, sir.
So mu s square plus 1 square under root, and you know this factor can be written in terms of sine as sine of theta minus alpha or whatever. Correct?
Yes, sir.
And when this denominator is to get you the maxima when theta minus alpha is equal to 1, isn't it? When denominator is maximum, then force will be minimum. And that will happen for what value of theta? When theta is equal to, theta minus alpha is equal to how much? Theta minus alpha is equal to pi by 2. Agreed, class?
Yes, yes.
Yes.
It's a replication of what we have done. You know now that F minimum will be equal to how much? And commit it to memory, please. F minimum is mu s mg divided by mu s square plus 1 whole under the root. They may ask, what is theta here? What can they ask? What is theta here? What will be that angle that you can calculate? What will be that angle? Tell me, class, what will be that angle? Theta minus, we know theta minus alpha. We know theta minus alpha is equal to how much? Pi by 2. So what is theta? Theta is equal to pi by 2 plus alpha. And what is alpha? What we have taken alpha to be, class? What is sine of the angle alpha? What is cos of the angle alpha? Please let me know. What is tan of the angle alpha, if I may ask? Check the equation that I have taken. Check the equation that I have taken. Do check the equation. What I would have taken should be, there should be a plus over here, right? Will it be? Check once. Check and confirm, class.
So then sine alpha would be 1 by under root mu s square plus 1.
There'll be a plus, right? First, all of you agreed. There'll be a plus, correct? If I'm going with sine.
Yeah.
If I'm going with cos, then there'll be minus. If I'm going with sine, then there'll be plus, correct?
Yes.
Okay. So it'll be theta plus alpha, which is what to get me this as theta minus alpha. I change this. Okay? Pi by 2 minus alpha, right? And what is tan alpha then? Sin alpha by cos alpha. So sin alpha is how much to us? 1 divided by mu s square plus 1 under the root. This is sin alpha. And this divided by what we have? Cos alpha. So cos alpha is mu s divided by mu s square plus 1, the same under root. What do we get this as? 1 by mu s. Do check, class, yes or no? Is it?
Yes.
So alpha we know from here is nothing but tan inverse 1 by mu s. It's mechanical now, nothing much left. You should be aware of this value. Don't presume it to be in the direction taken by us earlier. This may not be the direction. If you want to decrease, then you should change angle. Right, class? Getting it?
Yes, sir.
Get all of you? Did you get all of you? Take your time if you want to. Is it okay? Well received?
Yes, sir.
Okay. Getting back to the question which I did start with, this one. This one. I'm going back to this question. Will make you right. Shall I change now the working on board? Take a new
Yes,
leaf. Okay. Look over here. What was given to you? There is a block on which another block is placed. This is placed on a smooth surface, mu is equal to 0, and there is enough force of friction between these two blocks. Or mu k. You will take as it falls. M2, M1. On M1 is applied a force which changes with time. K is a constant, T is time. Very important question, class. An important question from Irodov. Mu is 0. You have been allocated value of mu s and mu k both. There's a force kT that is linearly increasing with time, is what it indicates. There is a force which is linearly increasing with time, and it acts on mass M1. Is it okay? Force acts on mass M1. Am I clear?
Yes, sir.
Yes, sir.
What will happen? What will be the observation? What kind of motion you will observe starting from zero? You start from zilch, there was no force. Then you started increasing time. Accordingly, force is to magnify, is to compound. What will happen? What kind of motion you expect to be?
Sir, until one point in time, there'll be no motion of the body. But when KT is equal to M1 M1G mu K M1G, then the block M1 will start moving forward, and I think the block M2 will start moving backward.
Okay. So when M1 moves forward, then M2 will move backward according to you.
Yes, sir.
Okay. And what will happen when the amount that you are referring to is not that high?
So there will be no motion of the no. Both the blocks will move forward with KT.
Now what you spoke is something which I can lay credence to. Whatever be the amount of force, one thing we are sure of, there is on this system per se no force to resist forward force. Agree?
Yes, sir.
Forward force is KT, and on this system, when you talk of M1, M2 as a unit, getting it? When you talk of M1, M2 as a unit, then there is no force to oppose motion in the forward direction. Let me ask you to draw a free body diagram to make it apparent to you. On M1, there is a force which you have applied, KT, correct? Agreed, class? Yes or no?
Yes, sir.
Yes.
Now this force will try move M1 forward. Agreed?
Yes, sir.
Okay, I want to decide on direction of friction between M1 and M2. So what should be the direction of friction between M1 and M2? Will there be
Backward.
any friction or not?
Backward.
Will there be any friction or not? Yes, there will
There
be.
will
And how
be.
do we get to know? How do we consolidate our position on there will be friction? May I please be highlighted on it?
There's a force which is trying to bring about relative acceleration, so
Okay, and relative acceleration will be in which direction?
forward.
Forward direction as seen from, of what as seen from what?
Of M1 as seen from M2.
Correct. So on M1, force of friction will act in which direction?
Backward.
Backward. That is what I marked. This is Fs. Okay. Normal force upward. M1T downward. Next, on M2, tell me, what about M2? What about M2? What about M2? The background be check, please. Yeah, what about M2?
So mg and normal, and then there's the friction Fs acting in the forward direction.
G, normal, take it normal, okay, let me mark it. Normal. And then one normal from ground as well, right? So N
Yes.
prime. Yeah. Any other force?
So friction in the
Friction.
forward direction.
Friction in the forward. Good. force of friction in the forward direction. Okay. Is there any resistance to this force of friction? Is there any resistance to this force of friction? Force of friction on M2? Is there any resistance to it? Any opposition to it? Yes or no?
No, because the ground has no friction.
Exactly. If there is no opposition, could you please tell me why will it remain at rest even with this application? Can it remain at rest? Can it ever
No.
remain at rest, class? Whatever be the value
No.
of Fs, will it be at rest? Is it possible for it to be at rest as seen from Earth?
No.
No. So whatever be the value of Kt, however small it may be, M2 will move. Agreed? Agreed or not?
Yes,
Are
yes.
you all in agreement? M2 will move, yes or no?
Yes, sir. As long as
Yes.
he isn't zero.
M2 will move, and if M2 will move, now there can be some doubt. Will M1 follow? Will M1 move with M2 or not? We are sure of the case which is being depicted on board indicates they are to move together as I have marked Fs. Agreed?
So
Fs I have marked. That is there on board. What I have marked is Fs. If it's marked Fs, there will be no relative motion between M1 and M2 is what I am beginning with. That there is no relative motion between M1 and M2. Getting it, class? And if I am to advocate there will be no relative motion between M1 and M2, it will be true till the time Fs reaches value Fs maximum. Agreement?
Yes,
Sir, I didn't
sir.
understand. Could you repeat
I
it
said
again?
if is mark Fs, what I'm trying to suggest, what I'm suggestive of. If I'm marking Fs here and marking Fs here, what I'm suggestive of is there being no relative motion between M1 and M2. Am I right on this? Is not that what I'm suggesting?
so what is given about KT?
Come again?
What is given about KT, the force?
Kt is a continuously increasing force here. It will increase with time.
Oh,
Okay? I have marked Fs. That means I'm assuming that at this point in time, when Fs being marked and Fs being marked, not Fs maximum or Fk, then at this point in time, there is no relative motion between M1 and M2. Therefore, they are moving together. Got it?
Oh, okay. Until Fs max.
Right.
yeah, until Fs.
Till the time Fs operates, they are to move together. Correct?
Yes, sir.
And Fs will operate till the time Kt is balanced by Fs. Agreed?
Yes. Sir.
And that will happen up to the maximum value of Fs, which is Fs max. Agreed?
Yes. Sir.
So till the time I reach Fs max, we are comfortable in our skin. There will be no relative motion between M1 and M2. Agreed? Endorsing it?
Yes.
So from beginning up to Fs maximum, they will move together. Are you all subscribing to this statement of mine?
Yes.
Yes.
Please write that down. We will increase KT. We are increasing till the time Fs max reaches Fs maximum. They will move together, which is what to say that Fs maximum is the susceptible point. Before of that, we all are good in the concept of two bodies moving as a unit, right? Two bodies moving as a unit, right, class?
Yes. Yes, sir.
And moving with what acceleration? Fs is equal to mass m2 into acceleration. You can take any body, you'll get same value of acceleration, which from here is how much to read. Can you tell anyone? Fs is equal to m into a is what is the acceleration with which it is moving. Fs is equal to m into a. And incidentally, what we have Fs equal to, you get from the two equations. Second equation is reading Fs is equal to a, m to a, and first we'll read Kt minus Fs is equal to m1a, right? Right? From inertial frame,
Yes, sir.
right or not?
Yes, sir.
Yes. Yes, sir.
Adding them gets us Kt divided by m1 plus m2 is equal to a. Right? What will happen to acceleration from here, anyone? What will happen to acceleration, anyone? Please tell me. What is happening to acceleration? Are they moving with same acceleration? To which the answer is yes. And why the answer is yes? Because Fs being shown over here, they will move with same acceleration. And they will move with what kind of acceleration? Acceleration is function of time. What kind of function of time? Can we say it to be
Linear.
linear function of time?
Linear. Yes, sir.
Okay, so I draw a plot for you. Linear function of time. It goes this way. What is theta here or tan theta? Tan theta is equal to how much, class? Tell me. A divided by?
M1 plus
So this is what we are getting. This is what we are getting as acceleration time plot. And the bodies are moving with same acceleration. Up to what point this is to be the case, class?
Fs max.
So let us find Fs first. Fs is how much from here? M2 into Kt divided by M1 plus M2, correct? From this equation, right? Clear? Is it clear?
Yes, sir.
Yes, sir.
And what do we have as inequality always applicable? Fs is less than or equal to Fs max. Right? So M2 Kt divided by M1 plus M2 is less than or equal to, tell me class.
Mu s n. Mu s
Mu
n.
s into n. What n? Which n?
Normal between M1 and M2.
Which is n marked over here, and n is equal to how much? M1G,
M1G.
right? Which is to get me M2K T less than or equal to mu s M1, M1 plus M2 into G, correct? Which will get me T less than or equal to mu s M1, m1 plus m2 into g divided by k m2. Right, class? You check.
Yes, sir.
So they will move together till what time? Till mu s m1 plus m2 into g divided by k m2. Now, as I was indicating earlier, that this can be rephrased at what time motion will begin. They may ask you till what time they will move together, or at what time relative motion will get set. For both the cases, you have the same answer. Is it okay, class? Is it okay?
Yes.
Yeah.
Yeah, okay. See to it step by step, as I'm to ask you to further with plot. You'll have to further with plot, but see to it step by step. Coffee, I get you. Right. I'll get you. What is that or what? I think there is got over it seems. Is it okay? Anything to ask on what we have dealt with? Anyone? Are you all there?
Yes, sir.
Yes, sir.
Yes, sir.
Is it okay what we have dealt with?
Yes, sir.
Okay. You require some time for it to sink. Take your time. Those who are through, they will further the plot. Please further with this plot, because here what I want to mark is Fs operational. So till Fs being operational, they moved as one block. This is Fs max operation. What will happen if we go beyond this value of Fs max? Fk will start acting, that is an obvious. What will happen to acceleration? When Fk will act, what will happen to acceleration of M2 class?
It will reduce.
It will reduce, but it will be constant, right?
Yeah.
Okay. So it drops a little, let us say, and constant. Okay. What about M1?
Increase.
That will increase.
M1 will increase.
Yeah.
And how can you justify that increment based on equation?
Because KT minus FS is M1A, and since FK is lesser than FS max, so M1A will increase.
If
So
I mark this as A, then at A, what was the equation for M1 to follow just before relative motion is what I write. It was KT minus Fs max is equal to M1A, right?
Yes, sir.
Okay. Now what happens? It starts moving, correct?
Yes.
Starts moving, then Fs will change to Kt minus Fk is equal to M1A, correct?
Yes, sir.
What is slope now? K by M1T. What is intercept now? Fk by M1 is equal to A. So look at the slope, please. Slope now is K by M1. And till the time they were moving together, slope was K by M1 plus M2, right, class? Correct?
Yes.
What was
Yes,
slope
sir.
over here? What was slope over here? Slope was this factor. Which factor? Check here. Where's the x? This one. This was slope, correct? When they are moving together. Say me yes or no?
Yes, sir.
And what is the slope now? This one. Yeah? K by M1. Getting it, class?
Yes, sir.
So what will happen to slope? Slope will increase,
Increase.
right? Slope will increase. It will go this way now. Do check, class. Do check everything. Please do check. See to it. It's clear to you. No hurry. It's an important question. Okay? Do check. Shall I write the equation yet again for you? This was the slope when they were moving together, which we have written. Agreed, class? Agreed?
Yes.
And what is the slope when Fk started acting? The slope being this one, correct? Right?
Yes, sir.
So what has happened to slope? It has increased or decreased?
It increased.
So when you are talking about acceleration of m1, then this will be the plot. When you're talking about acceleration of m2, then this will be the plot. M2 will not, but M1 certainly will change, right? M2 is stagnating, but M1 is increasing. It's a very important question, class. Please take time, see that it sinks, it is being received and accepted. Do you want more time on this?
So kinetic friction always stays constant?
Yeah, kinetic friction is constant. That statement we made the other day, right? Kinetic friction will remain constant. And that is mu k normal. Mu k into normal. Are we through this one?
So just a minute, please.
Right. Mandavi, Mandavi, what is the thing? Why can't today? Oh, it got over 2 days back, I think. Is it today? Are you sure? Shall we further?
Yes, sir.
So
Okay.
could we have a break of like 5 minutes?
Okay, take. By the way, okay, we'll have a break of 5 minutes. We'll take 5 minutes break. Okay. So we meet in 5 minutes, right?
Yes, sir.
Okay.
So I have a doubt.
Yeah, dear, tell me.
How do after we got that time is lesser than or equal to mu s m1 plus m2g by km2.
All right.
How did we get the equality sign?
Equality, see, here what do we get to see? At t, t is what? What do we write? Fs maximum is equal to Fs max from here. Fs is less than or equal to Fs maximum, right here?
Yeah.
Okay. Fs maximum is how much for us? Mu s m1g, right?
Yeah.
And Fs is how much to us? Mass into acceleration?
Yeah.
Okay. Now what do we get to see from here? T should be less than or equal to, correct?
Yeah.
Please see the algorithm that we are following there.
Yeah, I got.
Is this algorithm clear, this one?
Yeah, that one's clear.
And why so?
Because Fs max always greater than Fs.
Okay. Now is this part clear? Why is Fs this much?
Yeah.
Okay. What is Fs maximum? Is that clear? Fs maximum mu?
Yeah.
Okay. Now what I did, I just equated it and I got T less than or equal to this, correct?
Yeah.
They have to start relative motion will start, correct? So when can relative motion start is being asked. When according to you relative motion can start? What from here will you extrapolate?
Relative motion will start when Fs max. Then Fs.
Fs max is acting, correct?
Yeah. Yeah.
Okay. And Fs max will act when T is either less than or equal to this value. Is it so? Till
Yeah.
what time Fs was acting? Till the time Fs was acting, you are having which equation applicable? This equation, correct?
Yeah.
So this T relates to what
Okay.
value?
Yeah, I got it.
Till the
Fs.
time Fs was acting. Clear?
I got it. Yeah.
Okay, shall we meet? Shall we reconcile, class?
Yes.
All of you in?
Yes, sir.
Yes. Okay. Didn't want to dampen your spirit of break. Just to share with you, today we were so occupied. We had early in the morning few pieces of watermelon and so occupied that post which we have not had anything, me and my wife both. And she is over here present with me as we came directly from somewhere, some documentation was on today. So we are still on empty stomach. Nonetheless, after the class, we may have something. So today is a fasting which was volunteer. Okay, let's get started with the portion, shall we?
Yes, sir.
Okay. Now, what is given to us in the questions that I have furnished or I have shared with you? One of the question which I would wish to discuss with you being the circle track, and on that there being a parabola, and the parabola was moving with,
So this was an advanced question, right?
yes,
Okay, sir.
if this is common I may discuss. As per my
Yes.
comprehension, this can be common, so I have picked up. If it's not common, I will not discuss. I will not take time of class for this discussion. We'll be discussing in detail the other day we meet. Okay? So it's up to you to decide, is it common?
Yes, sir. I think
Yes,
it is
sir.
common.
You can do it.
Yeah.
Is it common, class?
Yes, sir.
Yes, sir.
Okay. So tell me, what was the approach to this question? What came to you? Because I'll hint you and will want you to work on it. Any hint that you want. This parabola equation was given to us, and that being x square equal to y, correct? Isn't it, class? X square is equal to y. Was it given to us?
So I think x equal to y squared.
For one value of x, you will have two values of y over here, isn't it? So x is equal to, not this one, y square is equal to x, correct?
Yes, sir, this one.
This is given for one value of x. So this was given to us, and that is what I take. Please see to it that initially this was having its apex at, if you're aware of it, it was having its apex over here. Are you aware of apex of parabola?
Yes, sir.
Okay, so that was the apex. After time t, or as function of time t, it's moving with certain speed. What was given to us? 3, correct?
Yes, sir. It was 3.
Yes.
So what will be the equation of parabola after time t? Can you write equation of parabola after time t? What will happen to x? Now x will be, the function is moving forward, so x minus 3t. Will it be? Check, class. Now when x is equal to 3t, y is equal to 0, correct? When x is equal
So how
to,
is
this will move
sorry,
forward from here to here. So how much is this? 3t, correct?
that's given in the question?
No, it's not given. It's given that initially it was at the origin, the apex, and then it starts moving in the forward direction with a speed 3 meters per second. That is given to us, right?
The apex.
So in time t, what distance will it move forward? 3t, correct? This should be known to you mathematically, that if a function is defined by fx, and that's very simple to comprehend, by the way, and then this function moves forward by a certain distance, keeping its shape intact. It moves forward by distance b. then this can be written as fx minus b. Is this known to you?
Yes, sir. You gave this while teaching projectile.
Yeah. The forward, and that's simple there. Why? Because y, what is this fx? Y, right? Here, when x is equal to 0 in this case, then y is 0, correct? Here, when x is equal to b, then y is 0, correct?
Yes, sir.
From there, we get to see that when the function moves forward, then x minus this amount. It's the same over here. This function was moving forward, so it is written by x minus vt. Is this clear, class? It was discussed in projectile motion, forward motion. I'm just writing it in terms of time, 3t. At any time, this will apply at any time, 1 second, 2 seconds, 3 seconds. You'll be able to justify your read. Is that clear? Okay. So this
Yes, sir.
equation of parabola as function of time and x. Now what about equation of circle? X squared plus y squared is equal to 17. Is this known to us? Equation of circle? X minus 0 whole square
Yes, sir.
Yes, yes, sir.
plus y minus 0 whole square is equal to r squared. This should be known to us. Are we aware of it?
Yes, sir.
No.
Yes, sir.
So this is the equation of circle. Now tell me at what time they want you to read it. At what time? Time was furnished in the question. What time they want you to read it?
So 1 second.
So
T
at
equal to
1
1 second.
second, y square, what will it read? Y square is equal to x minus 3, correct?
Yes, sir.
Yes, sir.
And equation of circle will remain. It has got nothing to do with time, so is equal to 17. Right, class?
Yes.
If we solve these equations, we'll get values of x and y. Do check. What are the values of x and y? What are the values of x and y? Can I get to know? What will be x, what will be y? Simple, not much. Check, class, just place the value of y square here. So x is squared.
Sir, x is 4 and y is 1.
Okay, I'll write that down. X is how much?
4,
X is 4. Okay, and y?
1.
Do we all subscribe to this value? Do check, class. Is it okay, class? Do check.
Yes. Yes, sir.
Okay, so let's draw for the case. Y is 1, so this is 1 to us. And this is 4 to us. This is 4 to us. I draw the case. So this will be root 17 then. Right.
Yes.
Yes, sir.
And this is as marked 4. Let me take a different mark. This is as marked. Oh, sorry. Four. And this is, excuse us for the magnitude, it's not appearing, not much commensurate with what being ideated. Okay. Now, Particle will move in which direction? In this direction, correct? This is the only direction it can move, agreed? See, one way of solving it will be to differentiate the equation, get dy by dt and accordingly dx by dt, correct? By differentiating, you get dy by dt. By differentiating, you get dx by dt. And then you can place the value of x there to get whatever is required. I think they asked for what will be speed of the particle, right, class?
Yes, yes, sir.
The other way out
Yes.
can be that you take this as v. This is the direction in which particle can move. Particle is bound to move in this direction. Agreement? It can move only in this direction, right?
Yes, sir.
Okay. So v is this to us, and in this direction, the motion is known to us, which is 3 meters per second. What is the motion in this direction? 3 meters per second, correct? And particle speed being asked, particle can move only in this direction. By the way, this 3 meters per second is for the parabola. It is not for the particle. Getting it, class?
Yes, sir.
Yeah. 3
Yeah,
meters
yeah.
per second is for parabola. Please be careful of it. 3 meters per second is a parabola. It in no way indicates that the particle is bound to move 3 meters per second in x direction. That is not what it indicates. It is just for us to show that particle is to follow circular track. So at any point in time, where should be the particle? Particle should be moving in the direction, wherever it is, it should be moving in the direction tangential to circle, correct?
Yes, sir.
So here it is moving in the direction tangential to the point where it is at what time? At t equal to 1. Do check the equation. No hurry.
Sir, I didn't understand why the particle would move tangential to the circle.
Particle is to follow circular track, right? Circle is not moving, isn't it? Circle is not moving. What is moving is parabola, correct?
Yes, yes, sir.
So it is always to follow circular track, correct? Wherever it
Yes.
is. That is the only direction it can move. It cannot move radially, correct?
Okay.
Particle cannot move radially. It will have to follow circular track. And if it is following circular track, it should move on a circle. Agreement? Do you agree there?
Yes, sir.
Okay. Now, question is, how will find dy by dt and how will find dx by dt? Anyone? How to find it? First from the equation, then I'll get you a short form as well. Now, equations with as being x square plus y square is equal to 17, right?
Yes, sir.
And y square is equal to how much? I write over here for you. Y square is equal to x minus 3t. And this is equal to 17, right, class?
Yes,
Yes.
sir.
Now we have all in x, right? Let us differentiate is twice of x dx by dt plus dx by dt minus 3 is equal to 0, correct? Correct? Correct, class?
Yes, sir.
Yes, sir.
Just differentiating with respect to time, nothing much. So twice of x plus 1 dx by dt is equal to 3, right? Right,
Yes,
class?
sir.
So dx by dt, how much from here? Dx by dt is equal to 3 divided by 2x plus 1. Isn't it?
Yes, sir.
And we require dx by dt at what time? At t equal to, you know. But at that time, you also know what will be the value of x. So 3 divided by, what shall I place for x? What did we get?
4.
4. So 3 divided by 8 plus 1. Right, class?
So 1 by 3.
So this will get us 1 by 3. Okay? Okay,
Yes.
class? So x component of this particle is how much? Vx is equal to 1 by 3. Is it okay? If you know Vx, you can calculate V provided angle is known to us. An angle is known to us. What is the angle? This angle. Which angle? Show you. This angle is what we want, right? And we get that angle? And we get that angle?
So which angle?
The angle which I have shown by red or by white, now I'm showing by red. This angle. We want that angle. If this angle is theta, this angle 90, this is 90 minus theta, right?
Yes.
Yeah.
Yes, sir.
So this will be how much? Theta again, correct?
Yes, sir.
Yes.
So how much will be this? 90 minus theta, right? Do you check?
Yes, sir.
What can we write then? V cos 90 minus theta is equal to 1 by 3, is it?
Yes, sir.
So V sine theta is equal to 1 by 3, is it?
Yes, sir.
So V is equal to 1 by 3 sine theta. And how much is sine theta from there? Tell me, please. From the triangle, you can tell me sine theta? Perpendicular by hypotenuse, correct?
Yes, sir. 1 by root 70.
So 1 by root 70. This will be the answer. Root 17 by 3. You could have got the same. Once you have got dx by dt, you can change it to y the equation. For example, over here, we would have changed it to y. How? Instead of x, we will write y squared plus 3t, correct? Whole square plus y squared is equal to 17. And then we would have gone for differentiation, whichever way you want. This seems to be easier, so I followed this method. Okay? Check class, important question. Unseen question. Check every step. Is clear?
Yes, sir.
Shall we change?
Yes, sir.
Okay. I have a question for you next. There are 3 cylinders arranged as shown in the figure. Their centers form an equilateral triangle. What should be the minimum value of theta beyond which this arrangement will collapse? What should be the minimum value of theta such that if we decrease theta beyond that value, system will not sustain? Am I being received? Is it okay what the author did ask for?
Yes, sir.
Okay. This is one case. Second problem which I wish deal today is there are 3 balls kept touching each other, and the 4th one is above it. They're all identical. 4th one is above it. Is it okay how are they arranged? Kind of tetrahedral, 3 being on a plane and 4th evenly touching all the 3 atop them. Okay?
Yes, sir.
Okay. Now what being asked is the reaction of the ball atop on any of the 3 balls. Reaction of the sphere atop on any of the 3 spheres. What force the ball atop will apply on any of the 3 spheres? That is the question. Is it okay, class?
Yes, sir.
Okay. One at a time in a go. Let us take this one first, the one to the left. How will you go about this one? These are a few routine questions you will get at many a place. Okay, let me ask you a few questions, breaking it into certain compartments. Compartment number 1. If you decrease theta, initial being given to you 60 degree. If you decrease theta, which angle is 60 degree initially? This angle. Equilateral triangle. If you decrease theta, will that angle change? Or system per se as a combined effect of 3 cylinders will move down? What comes to you? A, change in angle. B, system descending, keeping the angle intact. Mind you, there isn't any friction present anywhere. Yes, please. What will happen?
So will it simply descend and keep the angle?
It is ought to simply descend. If it is not to, then there'll be some issues related to friction. Friction being absent, right?
Yes, sir.
So it is to simply descend, it is to simply move downwards. Okay. So 60 remains. Can we say that? 60 remains. Can we say that? 60 will not change. Can we say that? Yes or no? Angle remains. Equilateral triangle remains. Can we say that?
Yes, sir.
Drawing FBD for the cylinder atop, normal in this direction. Normal from the other one in this direction. Angle between them 60 degree. So what is the net force in the upward direction? Twice of n
Sine 60.
cos of the angle 30 degree. Right? That's the formula, right? You can use directly or you can break and see. Isn't it? N cos 30 from this side. N cos 30 from this side. So 2n cos 30, right? Same
Yes.
force. Is it okay, class?
Yes, sir.
Okay. So 2n cos 30 degree. And downward is what force to be seen? mg. Now, first equation for equilibrium state of cylinder at top of the other two is 2n cos of the angle 30 degree is equal to mg, right? Getting it?
Yes, sir.
Okay. What is the other equation to read? Next, I take free body diagram for the cylinder on the plaque. Okay. Good. Is it good, class?
Yes, sir.
Can we draw free body diagram for this cylinder? What are forces that will act on this cylinder? mg. Right.
So then the normal from the other two balls and the normal from the plank.
Okay. So normal from the upper one will act in this direction. Okay. The other one which you spoke of is normal from the other one which is in touch, right? But when it collapses, then this normal will cease to exist. From top, it will remain, it will continue. Collapsing means there is no touch, correct? So this
Yes.
normal will not have effect at the time when it is susceptible to collapse. Which normal will continue to act? The one from top. I'm referring to the one when it is vulnerable, when it is about to collapse. Are you getting, class? And collapsing means normal from the horizontal one isn't acting anymore. What about the other normal that will act? Agreed? Getting? Or shall we keep it over here? Are you being a guard now, overwhelmed? Or we're dealt a lot? Or you're still in a position to accept?
So we can do this question.
Okay. So normal from top is still acting, right? Top one will remain, correct? I'm not getting any answer. System started collapsing. System started collapsing. Normal from top, it is still on the top. About to leave. Bottom one, touching each other, but not pressing upon each other. There's no support. Touching each other they are, but they are not applying force on each other. There is a fissure. Tell me what component you'll get of this normal along inclination. The component that I get of mg along inclination, I write for you. It reads mg sine theta. What about component of normal along inclination? Anyone? Normal along inclination. Yes, please. You were saying something?
Sir, I said cos theta.
What cos theta? Please come again.
And mg cos theta.
Mg cos theta or n cos theta?
Well,
Mg cos down will be mg cos theta. No? This will
normal,
be
right?
mg cos. Achha, this will be mg cos theta, right?
Yeah.
So, are you of the opinion that it is to continue apply the same normal? The normal direction will remain same.
No.
Normal direction, triangle is maintained, but what will happen to with the inclination? Initially, it was making an angle 60 degrees. So initially, you can stretch and show that yes, this angle is equal to how much? This angle is equal to 60 degree, right? This angle 60 degree, this angle theta, okay? And accordingly, you get the other angle, which is this angle, right? Okay? When you change the inclination, when it descends, what will happen to the angle here? 60 degree, this 60 degree remains. This changes, correct? So this will also change, yes or no?
Yes, sir.
So how can we say that that will remain same? That is to change. Think about it. I'm in no hurry to press upon this question, but you need to think about this question. And we can further this. What I'm trying to suggest is, as you said, or as someone did comprehend, who was it? That normal will equate to mg cos theta. Firstly, normal and mg cos theta are in the same direction. So normal and mg cos theta are in the same direction or not is to be comprehended. The normal that I have drawn. What do you say about normal that is being drawn by me and mg cos theta? Are they in same direction? If they are in same direction, still agreement with same direction, go ahead with same direction. I'll accept it. They are in same direction means the total force in the direction downwards is how much for us? N plus mg cos theta. Is that the case? Please say whatever you are to present with solidarity. Don't be flimsy on it. Think about it. Get me an experimentation or think about it. Consolidate your thought. Redouble on it. Normal, mg cos theta. Think about their direction. Fine, I'm getting you some work. I'm assigning you some work. Normal that I have shown, mg cos theta that I have shown, A. Are they to be collinear? Write it down, class. Are they to be collinear? Fine. Written? Written?
Sir, after the system gets
After we have changed the angle,
Okay.
Are they to be collinear being asked? First is this, okay? Second is, what about normal on the sphere from Planck? Normal on the sphere from Planck. Is that normal collinear with mg cos theta or the normal shown? Is that normal collinear with mg cos theta or the normal shown?
So collinear with mg cos theta, right? Because
Or the normal, whichever, or both. Okay? Getting it? So to ask over here for you. Both must be thought over as we leave it for discussion. If you have had a thought, you want to share your thought with me right away, so be it. I'm open to it. Tell me. Any one of you. Any thoughts? What? Want to think? Yes, class.
yeah, so we'll think on it.
So if you want to think, then I'll add to your thinking, which is given a tetrahedral. Coming to the second question, which I have gotten you as food for thought. These balls are to form tetrahedral. Their center will form a tetrahedral structure. So in a tetrahedral, you'll glean on. Are you aware of tetrahedral shape, class? No? It has got 4 equilateral triangles, and it can easily be accommodated or just be fitted in a cube of, in any cube. Generally, we take a cube of dimension 1 unit. Depends on what is the dimension of tetrahedral. It can be easily or just fitted in a cube. It has got 4 equilateral faces, equilateral triangle faces. Tetrahedral not being dealt in chemistry as yet. Did you encounter in chemistry or not? Organic chemistry?
Yes, sir. Yeah, our teacher did tell us.
Okay. Did the teacher tell you about the angle that vertical will make with any side?
Was it 109, around 109 degrees?
So that is cos theta equal to 1 by root 3. If that angle is theta, then cos theta is equal to 1 by root 3. I doubt it is 109, somewhere 70 or so. 73, so the other angle 109. I'm referring to theta. Is it okay? Which angle is this? Side with the vertical. Is it okay? Clear? Center with the vertical. Cos theta 1 by root 3. This can be proven. So these are the two that we are leaving you with. Good. If you take that angle on face value, you ought to calculate what will be the reaction. It becomes very simple then. Second question is all about angle, cos theta 1 by root 3. That angle known, this question reduces to a very simple ask. Take this angle on face value, try to find force on the pink ball or by the pink ball on any of the 3 red balls. First, you'll have to find on the pink ball by the 3 balls, and then you can calculate by the pink ball on any of the 3 red balls. Okay, class?
Yes.
Yes.
sir.
Okay, we call it a day. Let me break our fast. Let my wife also break her fast. No water since morning. Right, let us then take your leave. Fine, class?
Okay. Thank you, sir.
Yes, sir.
Okay.
Thank you, sir.
Dear, thank you.
Thank you,
Keep
sir.
keep working on the questions as well. We'll take the question. There were many questions which we need to solve. Remember these, this kind. This also is a good one. Okay. V0, V1, this one was there. Correct? You'll be solving.
Yes, sir.
Okay. Okay.
Thank you, sir. Bye, sir.
Bye.
Thank you, sir. Bye, sir.
बारिश हो रहा है इसी के लिए हाँ यहाँ भी हो रहा है बारिश हर दिन हो ही जाता है थोड़ा थोड़ा हाँ सब ठीक है नहीं जैसे था वैसे ही और क्या वही बना रहे हैं सब्जी फल और क्या? बस